Hello and welcome to section 5.3. We're going to be working with angle bisectors today. We worked with perpendicular bisectors yesterday, and today we're going to talk about angle bisectors. So here's the answers to 5.2. This theorem here, proving the perpendicular bisectors theorem, I kind of walked through that. You have to prove that those two lengths are the same. Basically what you have is, since it's a perpendicular bisector, call this angle 1 and angle 2. Angle 1 is congruent to angle 2, right angle is congruency theorem. This is definition of a bisector. You have a reflexive side there, so it's side angle side, and then CP CTC. All right, 5.3. We're going to be working with angle bisectors. So an angle bisector takes an angle, splits it into two congruent angles, and then this point here, the theorem that they're going to talk, this lesson is very similar to the other lesson. Any point that's on the perpendicular or the angle bisector is going to be equidistant to the two sides. So there's theorems that involve that. I'm going to try to show you guys an easier way of doing this today. So these are the two theorems that, so if a point lies on the angle bisector, then it's equidistant to the two sides. The reason why these right angle marks are here is because when we're talking about distance, we're measuring along the perpendicular segment. And so that's why those are there. And then vice versa, it says, for the converse, if a point is in the interior of the angle, so that's on the inside of it, and it is equidistant from the sides of the angles, then it lies on the perpendicular bisector. So if these things happen here and here, then angle 1 is congruent to angle 2. Now, for me, what I would do is, instead of knowing these theorems here, these two triangles are congruent by, call that reflexive, angle, side. So CP CTC says that DB is equal to DC. Way easier in my opinion. And then here, again, these are congruent. So HL says those two triangles are congruent. Therefore, call that angle 1 and angle 2. Angle 1 is congruent to angle 2 by CP CTC. So really, this is nothing new. All it is proving triangles are congruent to show that parts are congruent. And those are actually both of the proofs. I just did both the proofs for you, kind of. It's a bunch of givens. Triangles are congruent, CP CTC. So it says find the measure of GFJ. GFJ. So that's this one right here. Well, let's see if the triangles are congruent. We have this angle. We have this side is congruent to this side. This is reflexive. So I'm not even using these theorems here. I'm just seeing whether or not the triangles are congruent. And they are by HL. So that means the two angles are congruent. So that means that's 42 degrees. This is always a weird question to go over. Basically, we have two triangles. These two sides are reflexive. Let's see, a soccer goalie's position relative to the ball and goalpost forms congruent angles as shown. Will the goalie have to move farther to block a shot towards the right goalpost R or the left goalpost L? And again, I don't really like this question, but so I think the book has this really skewed. But this is the angle bisector, and this point would make this perpendicular here, and then this perpendicular here, and I don't really see that. I'm just going to ignore this, but the answer to the book wants you to say that it's the same distance because of that theorem I just talked about, or you could say it's angle side, but I think this picture is drawn really skewed. So you can show the two triangles are congruent by angle side, then this distance here would have to be equal to that distance there. Don't worry about that question there. I think it's a terrible question. Okay, these two triangles are congruent here by angle side. And so it says find x, so that means we know that 5x is equal to 6x minus 5. We can solve that for x, so just using CP CTC. Do you have enough information to say that QS bisects PQR? So we're wondering, is 1 and 2, is 1 congruent to 2? And again, you don't have to use those new theorems, Mark what you know. You have a reflexive side here, and that's all you have. So you have side, side, but that's it. So your answer is no, not enough information. You need an angle in there. We're going to construct the incenter in class. It's found by drawing the three angle bisectors of a triangle. And so what that looks like is this here. I'll kind of go over my demo here. So if I draw the three angle bisectors, they meet at a point. So here's the angle bisector of C, B, and A. They meet here. It's called the incenter. And you can create a special circle called the inscribed circle. Now, the incenter has a special property, and that is equidistant to the sides of the triangles rather than the vertices. So this is our incenter here, right here, point P. This point is the same distance to each of the sides. So it's a new form of a center of a circle. So if I know any of those, they're all going to be the same. So this is equal to this and this and this. The red marks there indicate the angle bisectors. Now, technically, the angle bisectors continue to go through the triangle like that. But the book doesn't draw them to continue to go through. They stop them at the incenter point there. So here we have incenter. It's always going to be inside the triangle, unlike the circumcenter could be on the inside, the outside, or on the hypotenuse if it's a right triangle. And then it's equidistant to the three sides, which creates the inscribed circle. So those are the things that you need to know from this slide here. And we're going to be doing this construction in class when we do our construction day. Okay, so these are the types of problems that they're going to ask you. They're going to tell you that N is the incenter, or they're going to say that those are the angle bisectors. So what you need to know is that these three side lengths, or those three values, are the same. So if I can find one of them, I can find any of them. So it wants me to find ND. Well, ND is the same as NE, which is the same as NF. So you just have to find any of them. Sometimes they'll just tell you, like, this is like 5, and then you know that they're all 5. But sometimes you'll have to use the Pythagorean theorem in order to do these problems. So you're going to see a lot of Pythagorean theorems. We're going to call this fx there. So we're going to do x squared plus 16 squared equals 20 squared. And you might need a calculator. So let's see, 16 squared is 256, and that's 400. So we will subtract 256 from both sides, and then we're going to square root. And you might end up with decimals for this. That's okay. So when I square root both sides, I get 12 for my answer. And so that would make x 12, which makes that 12. So my answer is 12. So you're going to see some Pythagorean theorem questions. I'm going to do 25 as a class for you guys, or as a class tomorrow, in class when you guys get to class. I have 21 and 22 right here marked as challenge questions, but give them a try. So thanks, guys, for tuning in to 5.3.